Okay, so we're starting also the live. So let me start away. Hello everyone, welcome today for our session about Terraform Association or Associate Exam Preparation. Um, so I hope you can see my screen, everyone. Okay, to give you a quick overview about me, I think most of you already know me, so I will not give a long description. I am Microsoft MVP. My name is Muhammad Radwan. I have been working in the industry for more than 18 years now. And for more information, you can review my blog or follow me on Twitter or YouTube. Okay, let's go directly to the agenda. So today I'm going to explain, starting first where to ask questions and find resources for this series of, the preparing for Terraform Association exam. So I created a GitHub repo and we will know that. Then we will understand what are the exam objectives. After that, we will understand an overview about an end-to-end demo. So after we will cover the, the exam objectives, it's like a project at the end of the exam objectives. We will have an end-to-end demo that we can implement all what we have learned and also including CI/CD and pipelines. Then we will understand what is the preparation plan and then including that understand infrastructure as code, introduction to infrastructure as code with Terraform, install Terraform demo, and build the infrastructure with Terraform, changing infrastructure with Terraform demo, destroy infrastructure with Terraform a demo, and create resources dependencies, define input variables, query data with output variables, store remote state, Terraform FMT and validate, and tint resource, and notes at the end. So as I explained, I have a repo created on GitHub. So you can just go for this repo. Please click watch, click star, and just click issues. So if you have any question or issue or any inquiry, then you can just, first try to search with an existing issue first before you ask a new question or ask a new issue. So make sure to search first. And then if you couldn't find your answer, just open a new one. And also make sure to review the rules for asking questions or the raising an issue because the issue must has the minimum quality of the raising that issue. So you can review that. And all the links will be in the YouTube video. I will send that later. Feedback is very important to continue. Actually, I usually give a survey where people can give the feedback and understand how can I improve, what you would like to see in the next session and so on. So now I just disable that or I just get rid of that. And instead, I will use the YouTube channel as the place for the feedback. So please, again, I would kindly ask you to go and give me the feedback so I can understand it is really worth to continue. So everyone should be muted. So it is worth to continue or not. So yes, to just summarize that. So any feedback, which is I would really appreciate. It's not like please go and give me feedback about understand what you would like to see next and what was better, what was needs improvement, and so on. And if you have a question or inquiry, use the GitHub. So this is how we will use YouTube and GitHub. Okay, so all what I'm going to explain now is the main source is HashiCorp Learn, the main website for Terraform. So I'm not going to take something outside from that. So all the information exists on HashiCorp Learn. So the exam cover 9 objectives. So let me explain to you them or let's get an overview of all of them quickly. Understand infrastructure as code, understand Terraform purpose, vs other infrastructure as code, Terraform basics, understand or demonstrate that you can use Terraform CLI, demonstrate that you can interact with Terraform modules, and demonstrate that you can navigate the Terraform workflow, demonstrate that you can implement and maintain state, and demonstrate that you can regenerate and modify Terraform configuration, and finally, demonstrate that you understand Terraform cloud and enterprise capabilities. As I explained, after the 9 objectives complete, we will have an end-to-end demo, which including building a very small application, web application, and packaging the application, building a CI/CD pipeline, and provision the environment on the cloud using the Terraform, and all of that. So the plan. So I divided the course or these sessions into 3 sessions or into 3 days. So in each session or in each day, I'm going to cover 3 objectives of the exam. So as you can see, this is the plan. And as I explained at the end of day 3 or session 3, we will have an end-to-end demo to complete all or to go through all the steps or all what we have learned in the previous. So because today is day 1 or session 1, so this is what we are going to cover today. The infrastructure as code, Terraform vs other infrastructure as code, and Terraform basics. So the first objective, understand infrastructure as code. So this objective is divided into section or 2 sub-objectives. The first is explain what infrastructure is, and the second is describe advantages of infrastructure pattern. So the first sub-objective is what is infrastructure as code. So let's look at the traditional infrastructure. If we get back to how we treat or how we working with the traditional if we get back to how we are working with traditional infrastructure, usually you have a server or you have infrastructure and you just make some changes with your infrastructure. Again, over years and years, you start making some changes. And here the problem that how we are going to replicate this server, because we keep changing the server over time. Installing software, changing some configuration of the server like ports, open port, or maybe changing any configuration of the virtual machine, the server, or the infrastructure in general. It doesn't have to be a virtual machine. So the problem here, replicating this server, if I want, let's say, for example, I want to have scalability of my application, and I want to increase the infrastructure. I want to have a disaster recovery infrastructure for my application. Because I want to upgrade, for example, the operating system or maybe the hardware. So all of that. So maybe also I need like a development environment or testing or pre-production environment. All of this, it's really difficult to have replications environment. So it is, I'm not sure if you face this before as me, but for me, I have seen this hundred of times. The teams bring a lot of documents or a very huge document to explain what is the process for replication the environment, and we go through all the process, we create the environment, but it's not working because it is still something is configured, but it is not on the other new machine. So scale up require downtime. No way, because we couldn't replicate the environment or the infrastructure. And again, I want to upgrade, or there is no way except to downtime, which is again it's a very problem. So vicious circle of manual process. So let's understand how this happen. So for example, if we look at the manual process, it usually you need to well documented that manual process so you can understand exactly what are the steps. And then it starts taking long time to implement this documentation. And then at the end, it has errors, which make you add more verification in the document and the process, which increase the process, which end up with more documentation, taking more time, more errors, add verification, and this is what happened. So it will end up with more process, more documentation, and more errors. So it could start with very small document, and then after time it's increased and then increased because you wanted to prevent all the errors that you faced while you try to replicate the manual process or to go through the manual process. And this is the main problem of the manual process. This is why, you treating your server as a pit because again you don't want anyone to touch the server because again you can't replicate it. So and this is why if you working with like operation team, they really care about the infrastructure or the server, as no, it is not allowed because they really, it's very hard to replicate that, which makes them very care about it and treat it as a bits. And this is what we are saying: stop treating your infrastructure as bits, instead treat them as a cattle. And the main idea here, you don't take, for example, the cow or the cattle inside your apartment, or you don't feed them with your hand, or you, so because again, for you it's just a group of cattle. If some of them is not exist, you can buy of the others or you can replace them, so you don't treat them as a pets. And this is the main idea of treating your infrastructure as a cattle instead of treating them as pets. So in order to do that, let's introduce the infrastructure and configuration as code. So the main idea here, we usually do a UI component so we can configure the infrastructure. Most of the infrastructure now, let's say you're creating a web application, so you just go for the UI. You're creating a virtual machine, you just go for the UI, and then start configuring this infrastructure. So moving to the infrastructure and configuration as code is just to stop doing that. We are not going to use the UI for configuring our infrastructure, neither the configuration. So the main idea, we will depends on code to configure our infrastructure. This is the main idea of infrastructure as code. Just get rid of having a UI for changing the component and just use the code. So let's understand very important, concept about declarative vs imperative infrastructure as code. So when we talk about imperative vs declarative, so when imperative or with imperative, it is explain what and how, but in declarative, it is what, not how. Here it is workflow, but here it is logic, not workflow. This is a procedure. It is the same as programming language. If you type line 1 before line 2, so line 1, sorry, line 1 will execute first, right? Because the order and the workflow is very important. This is how you write your development code, or any development code. But when we're talking about declarative, it doesn't matter, it is just functional. So you reach the final state by executing the order's steps. It must be go through the flow, but you reach here the final steps by executing the content with no order. It doesn't matter the order because again, it is not how it is not how, it is what. You just explain what. And this is very important when we're talking about the difference between declarative and imperative. So infrastructure as code workflow, and this is a general workflow. So it starts with a source control. So you put all your infrastructure as code in the source control. And once you want to make any changes, you just get the latest and just make the change. Once you complete the change, you don't usually run, update, or create or provision the infrastructure from your code on your local machine. The best practices usually is to push to push these changes to the remote repo and then run an automated build. And this automated build will get the latest and start either creating or updating the environment. So provision a new environment, or if it is already existing environment, just update this environment with the new amendment that you have made with the file. So again, you stop doing any change directly to the server using any UI component or anything. Everything must be done through the code. And this is what will produce what we called immutable environment, because I can trust this environment. There is no hands, you know, this environment is 100% completely provisioned using the infrastructure as code. So any change, I just go make the same circle or the same cycle again and again. This is why if I want to replicate or produce a new environment, just very easy, because I can trust the code and I can produce another environment and so on. And I am pretty sure that those environments are identical because it's come from the same code. Anyone has any question so far? Okay. So let's describe the advantages of infrastructure as code pattern. If we're talking about dev and IT, and just imagine if we have the infrastructure as code that's responsible for our environment. So it's very easily now to create or provision several environments, either the dev or the staging or the production. And this will help for deployment optimization, accelerate the delivery. And of course, I can have some KPIs or measurement like deployment rate, for example, mean time to repair. All of this measurement I can keep measuring them so I can understand, the health of my environment. So advantages of infrastructure as code. It is easily repeatable. It's very fast and I can rely on that. It's easily readable. I can just open the file and understand from the file what are the component of the infrastructure and the properties, the configuration, and so on. Operational creating with Terraform plan. I mean certainty with Terraform plan. Terraform has what we call plan. It is something like dry run, so it gives you the ability to understand what will happen if you run that. We will go exactly and understand that, but it's very important to understand in general the advantages of infrastructure as code. Standardized environments builds, because once you have the code and you can make sure that this your standard environment following these practices or following these constraints or this standard in your organization. Quick provision development environment. Of course, it's very easy to create a development environment or maybe disaster recovery. Let's say your server has a problem or you want to, let's say, upgrade, or you want to have a problem about the server. Just create a disaster recovery server and just move your application or maybe deploy your application very quickly to that server, and this will happen very easily. So advantages of Terraform. Terraform has main three advantages. The first is it's platform agnostic. And this is really one of the most important feature or advantage of Terraform. Because with Terraform, you can work with different, for example, if we're talking about cloud provider, and of course, by the way, Terraform is not only working for cloud, Terraform can work with some of them or many of them is on premises, and it is not only as a cloud solution or cloud providers. So Terraform is platform agnostics, which means that you can have one file or the configuration file or Terraform that can interact with several platforms. And this is really, it's amazing feature. Just imagine if we're talking comparing Terraform to ARM or Azure Resource Manager, for example. With ARM, you are only interacting with Azure as a cloud provider. But with Terraform, for example, in one file, you can interact with Azure, with GCP, and AWS as well. in the same even file. So this is really amazing to have a platform agnostics, which also give you the ability with the concept of multi-cloud, that we usually say like don't put your eggs in one basket. So it's a very important concept about multi-cloud, and I think this will be covered in day 2 or session 2. State management, one of the very important feature for Terraform is managing state. How you are going to understand, or how Terraform is writing the state to a state file so it can understand what is the last state of the file. And of course, operator with confidence. You have a full confidence because you can trust that your code can always produce the same environment again and again. Okay, introduction to infrastructure as code with Terraform. So again, all the information, all the source coming from HashiCorp Learn. And in this Learn, you can see that you can do this, what I'm going to show you now, you can do that with either AWS or with Azure or with GCP, Google Cloud. But for me, I prefer to use that with Azure. So, but again, for you with your exercise, for example, you can go with that with any cloud provider from your preferences. Of course, it is not the same syntax when we're talking about the syntax for the cloud provider itself because it's a different plugin, but it will be almost the same. Okay, so in these demos, we have several demos. So the first is how to install Terraform, and then the second will how to build the infrastructure, and then the third changing infrastructure, and then destroy infrastructure, create resources dependencies, define input variables, and then query data with output variables, store remote state. So this is the 8 demos that we will see. Of course, there is other demos. This is why the session will take 2 hours to cover that. So let's start with installing Terraform and building infrastructure. So this virtual machine, I'm going to use it. So let's start with installing Terraform. It's very easy, install. Just if I Google that, this is the one. Yes, this is the one. No, this is not install Terraform. Let's say download. Yes, so as you can see, once I open Terraform, as you can see, I have different bits based on the operating system. So this is for Mac OS, this is for Linux, and since I am on Windows, again, you can work with which or either platforms you prefer. I- I'm on Windows, so I will use that. So just I will download. So as you can see, this will download the plugin. I just extract that. Once you extract, it just as you can see, it's just an exe for the plugin. So I will just put it here in the C drive. And once I put that, I will just open the environment variable. So as you can see, there is a path here, and I will just make sure to add this path to this here. So here, as you can see, this is the path. You just create new and add your path to the Terraform here. Once you installed, you can just open Bash or open command line. I prefer Bash. So, and just write or type Terraform. Once this command executed in this way, it means it's working correctly. So this is the first part. The second part, because I'm going to interact with Azure, so I need Azure CLI. So just, of course, it's installed on my machine. If you don't, just Azure CLI, download, and again, it will be very easy. Just download it, and it's an MSI, and double click, and you will install that. And to make sure it is installed on your machine, let me here see AZ, and then this will display the command if it is installed. If it is not, it will display an error. So as you can see, this is Azure CLI, it's installed. The third step is to log in to Azure. And in order to log in, I just type AZ login. So this will prompt it for authenticating to the Azure, and I will just using the authentication. I already did that. So I will close this. So this is the first part, is just to install Terraform. Okay, the second part is building the infrastructure, the second demo for that. And in order to do that, I copy that. Let me show you here. So as you can see, this is my Azure subscription. So if I went for resource groups, this is the current resource groups. And for people that they don't know Azure or resource group, just imagine that resource group is just a directory or a folder that hold your resources or your cloud resources for Azure. So I will just create, as you can see, this is the current resources. So I will just create a new folder here in let's say Terraform session. So this will be my directory. And I will create a file called main.tf. Sorry, let's be empty now. .tf. Not here. cd. I created the file outside, so I will create it here. So now, as you can see, I created, this is just an empty file, and I will open the file with Visual Studio Code. Let me here paste my code. So as you can see here, I have 3 blocks of code. Don't read that. So the first is a Terraform block, which includes the required providers, and the second is the provider, and the third is the resource. So as you can see here, the provider including Azure ARM, and this is the version of the provider. And here, this is the resource, which will, I just say, create a resource group. And here, this is the name of the resource group, the ID. And here, this is the name on the Azure Cloud. And here, this will be the location of the resource group. So let's save this file. And now, once I create that, let's initialize and see what will happen. So I will just write Terraform initialize. So once I initialize, just examine what will happen. As you can see, just make sure that you can see everything and you can notice everything. So as you can see, this folder created .terraform, this file also created .terraform.log.hcl. So let's understand exactly what happened. So first, let's go for this. As you can see, if I open that, it's just a library. As you can see, this is a provider. This is just a plugin to work with Azure, which is, you know, just imagine it's a plugin that can interact with the API of Azure. And also this file is very important, and it explained well here. As you can see, Terraform has created a log file to record the provider selection it made above. So all your provider is stored here. So for example, I can open that. Let me open with Visual Studio Code as well. So as you can see, this is the provider here, Azure RM, and this is the version, and this is the constraint, the hashes. So this is the log file. And as you can see, it's guaranteed to make the same selection by default when you run Terraform initialize in the future. So now I prepare my directory or my folder to work with Terraform, which means that I am ready to work with Terraform. This doesn't do anything except two things as we explained. Just install the required provider based on, the main idea, it's just scanning here in the Terraform file, configuration file, to understand what is the provider exists, and just download this, and also creating this log file, which including the provider's information. So next time you run initialized, it will understand what is the existing provider. So you don't need to download it again. This is the main idea of this log file. Okay, now we are ready. Let's open the Terraform. This is the cloud here, my cloud. So let's run. So as we explained, or as I explained, the first demo is just run a resource group, empty resource group. And just to remind you, what is the name of the resource group? It's called Terraform Exam RG. So let's run Terraform now. So in order to run that, I can run that based on several options. Let's start with the plan. So I can say Terraform plan. So just imagine plan is it's just a dry run. It's just like you are trying it. It is not an actual execution. So if I say Terraform plan, this will execute that. Let me also show you here. As you can see, there is some files created here. The TF state and also TF state log info, and the plan is still executed. So as you can see, this file created and deleted after the plan executed, and this is very important. So we can see here, it say that this will be create, and it just explain that the resource group will be created, and we will understand exactly all this, what it's mean, the plus here and so on. So as you can see, plan one is to add, zero to change, one to add, zero to change, and zero to destroy. This is the summary of the plan. So now I can execute or apply. If I type Terraform apply. Look, very important here. So it happened again, this file. And also look at this note here. You didn't specify an out parameter. It's just telling me that because I didn't put. Can you see my screen? Because everyone can see my screen, right?
Yes.
Yeah.
Yes.
Okay, thank you. So as you can see, the last plan, it just say because I don't use an output, this is why it can't guarantee that the exact action will be prompted. And here, once I run apply, this means it's going to execute the plan. But as you can see here, it's just waiting for my confirmation. Just to mute someone because Okay. Yeah, so here it will ask for my confirmation, so I will type here yes. And in this case, let's just minimize this and bring the Azure resources. So this will execute and create or provision the resources. So just to give a little time, let's refresh from here. Of course, as you can see here, it just say here, apply complete, resource one added, zero changed, zero destroyed. And here, my resource group created using the Terraform. Okay, so let's look at the demo 2 here. Just to remember, should I examine resource on Azure? Navigate examine state file locally. Yes, let's look at the state file. Just type the notes so I can remember. So as you can see, what happened here, there is a new file called state.tf state, terraform.tf state. So if we open this file, we can see here, this is the created resources. This is the real infrastructure, which is the actual infrastructure. So for example here, this is the location, this is the name of the resource group, this is tags, there is no tags, and all the information is stored in the state. Okay, so also let's clear this. Also, I can show the state by command Terraform Show. So if I type Terraform Show, this will show me the state, which is I just opened uh, from just a few seconds, but it will open in the command line. Output all the state in the command line. I have also another command or utility called state, Terraform state. But if you run state only state, it is, it doesn't run alone. It just has many switches like list, MV, pull, push, replace provider, and so on. So for example, I can use list, let's say Terraform state list. This will list all the resources. So for example, let's say that you provision 100 of resources. So you want to, run state list. This will listing all the resources. And it's very important to understand that there is some read only. Uh, I mean switches with the state command, and there is some modifying. For example, MV, this will moving resources from the state, and this is not read only. But for example, list, this is just a read only. Okay, so this is for the list. Okay, so just show you here. Let's open this again. I will just copy the state file here and let me show you something. So I will just copy that in WinMerge so I can show you the different. And just imagine now or just see what I'm going to do. So what I'm going to do is, I think now I will end this demo. Yes, just to pull the steps. Yes. Before we go for another demo, just let's take the takeaways, or let's get the takeaways from the previous. So all resources will be on a GitHub and YouTube. Yes, this is very important. So for example, you know, I I have a document which include all what I'm explaining, or what I'm going to explain to you now, with all the description and the links and everything you will find it on the GitHub repo. So you don't need to type or anything, even the script or the Terraform configuration, everything will be on the GitHub. So just remember. Also, if you have any question, again, remember to ask the question on the GitHub. And the feedback, it will be on YouTube. Again, I'm really appreciate your feedback and I'm waiting for it so we can continue. Okay, so the takeaway is knowledge. Terraform configuration file. So you just describe, or you start explaining your infrastructure component or your entire data center or environment in the Terraform configuration file, which end or which has a TF extension. This is the Terraform configuration file. Um, Resource graph. So Terraform build a graph of all your resources and parallelizes the creation and modification of any non-dependent resource. For example, just imagine that, if the resource is not dependent on other resource, then Terraform will, run it at the same time. And as a result of that, Terraform build infrastructure with a very good efficiency as possible. Provider. So are the providers? So just imagine that Terraform is rely on a plugins which we called, or which they called, providers to interact with the remote system. So Terraform configuration file must declare which provider to use, and this can be installed using the Terraform initialize. And each provider has a set of resources, types, or data that Terraform can't manage. So configure a provider. I think, okay, let me, before we go here, but this is known. I want to configure a provider. So to configure a provider, you just need to have a provider block, which including the version. And as you can see, once you configure the provider, as you can see here, Azure RM. So all the resources, it will start with Azure RM underscore X underscore Y based on the resources. For example, as you can see here, Azure Resource Group, Azure Virtual Machine, Azure Network Interface Card, Azure IP address. So all the resources, it will be the same. And the same with AWS or GCP. And this is why it's very easy to distinguish between which resource to belong to which provider. Control Terraform version or other behavior. So don't be confused about the version of the plugin or the provider and the version of the Terraform. So if you want to control the Terraform version, or behavior of the Terraform, you changing that in the Terraform block. Constrain a provider version. If you want to put a constraint on the provider version, you just put the constraint here in the Terraform block. Alias, you know, you can use alias so you can distinguish between several providers based on data center or conditions, and later you can use the alias to refer to the desired provider using this syntax. For example, aws.east, aws.west. So it is like, you can use several providers. So let me give you like tips and the tricks for the exam. So how this could be in the exam, starting from the beginning. For example, it could ask you how you can constrain a provider version and give you an option, you know, if you, for example, constrain a provider version and may give you this part, but this is not to constrain, this is to configure a provider. Yes, you can put the version here, but for putting the constraint for the version, you put it in the Terraform block, not in the provider block. Of course, in the provider, I'm sorry, it is in the provider block inside the Terraform block. What else can become as well? Yes. This is also a potential question, or could, like for example, it may ask you how to control the behavior of the Terraform version. Like for example, it will just confuse you between the Terraform version and the plugin version. So for example, you put the version of the Terraform in the Terraform block, but you put the version of the provider in the provider block in the Terraform block. So this is the key, like thing that you need to make sure that you know the difference between them. Constrain a provider version. Yes, we talk about that. We talk about Alias. Okay, let's look at the Alias example. So as you can see here, this is like when I declare a provider, let's say this is AWS, for example. I can also declare another provider. And as you can see, I just give here a property called alias. And here I put it east. So in the resource, I can refer to the alias using the name of the provider dot the alias name. As you can see, for example, here, aws.east. And again, this could be expected in the exam to just asking you about how or it is possible to use several provider, in the same configuration file, which is yes, how, and of course it will be the alias, how you are going to use them by using the provider dot the alias name. So all of this, or all of what I'm explaining now, is a potential question for the exam. So Terraform initialize or end. So the Terraform initialize, it just initialize the project or folder which you are inside in, means download the plugin or the plugins that allows Terraform to interact with the needed providers that defines in the TF files. So as I explained, Terraform int is scanning all the TF files to understand which provider you are using, and just download this file and create the log file that I explained to you. And just don't get confused. If you want to upgrade the provider, you just need to use the switch upgrade. This is how you upgrade the provider. Terraform log file. We talk about the Terraform log file as I explained to you. So again, it is with the initialization you did for the first time, it will generate this file. And it is just within the current working directory. You should include this file in the source control. The main idea here, because you want to make sure that your team or anyone will use your configuration will use the same providers. And this is the main idea. It also belongs to all the configuration, not for a specific, or modules. So like it is not created for each module. It's just created for the whole configuration. And all of that is a potential questions. For example, it could ask you how you are going to upgrade the providers. It could ask you what is the need uh, of the Terraform log.hcl. It could ask you also if the extension is correct. Maybe it will just say terraform.log.hce, or lf. So make sure that you understand exactly, all the information that I'm explaining to you. I will pause here and ask if there is anyone has any question. Okay, I can see some people asking on the live, what immutable environment? Uh, Immutable environment, it means that it is not changeable, like you can't change that by just going to the environment and change it. You just need to, you know, trust that it is immutable, and you're doing the immutable by following this process. Immutable environment, it's an environment that once created, you can't change it. Okay, someone answered that. Okay, clear now. How to check the logs after running Terraform apply? Okay, the most important thing is that we keep the question around the parts of the objectives of the exam. So it is not, for example, you can ask any question. Even for now, by the way, When you asking question on GitHub, I'm expecting that you will asking questions related to the first three objectives that I explained. For example, there is no point that you're asking now something on the objective 5 or 6 that, let's say, for example, building modules, which will be in session in day 2, for example. So keep the question around the scope of the session. How to check being the or to check the deployment status in Azure portal. I don't see any document in GitHub. Okay, yes. The question here about the document, all the documents will be on GitHub after I complete it. I will just again, like complete them. And this is why I told you, or I told everyone to make watch on the repo. So once I update the document or maybe a question, anyone ask a question or anyone answer the question, and also you can you can also ask and answer. I mean, for example, someone may of you ask a question, another one can answer, and so on. So once I update the documents on the repo, including the presentation and everything, then you will get notified if you click on watch. So please remember to click on watch. Okay, I answered this question. So let me now move here. Okay, Terraform plan. So when we run Terraform plan, this is generate an execution plan and it displayed this execution plan to the output. But if you remember, there was a warning that I didn't put an out as a as a switch with my execution plan. And this means that the execution plan will be only displayed to the output or the command line, but it will not be saved as a file. And this is really very important. I will explain it in the next demo. Okay, Terraform apply. So apply the configuration in the execution plan by the running or by running Terraform apply. The command line output shows the execution plan and will always prompt you for approval. So it will not execute without your approval first. I can also, as I explained, specify a switch without, so I can put a plan name, and this will generate a plan as a file, not just on the output. If you remember, the plan or not the plan, the TFS state, or there is some temporary file, which is the plan, temporary file for the plan generated, but after the plan executed, the file deleted. But if I put an output, this will create the plan. Okay, Terraform state. So we saw the Terraform state, and just to understand that Terraform write into this file. Sorry, I can see someone is sharing his screen. What you are doing? I'm sorry. So everyone can see me, right?
Yes.
Yes.
Okay. So Terraform state. So Terraform just store the state in this file, including the name of the resource, the IDs, the properties, which we call the real infrastructure. It could also contain sensitive value, and this is really very important, like credentials, for example. And this will be plain text. And some people will say, oh, this is really like dangerous. And this is why you must treat the state file as as a secret. Like for example, don't put the state file in the source control or the version control. And by the way, even if you put the file in the version control and you delete it later, but still the secret will be in the history or the sensitive information. So never put the state file in the version control. Treat the state file as a secret. This is why you must save the state file in a very secure. So treat the state file as it is a sensitive data because it's always save the information in the state file. And this all of what I'm telling you now is a potential question for for the exam. For example, it will ask you, for example, you can have uh, you can have a switch where it is doesn't display the sensitive information to the command line or the output. However, this will be saved, still saved in the state file. And this could confuse you because it is not displayed on the output, but because the state file, it is like log and it needs this information. So you need to remember that state file always has a sensitive information. Okay, this is for the state file. Yes, another one is with when you work with large team, so the state file must store remotely. Instead, as you can see, for example, in the previous demo, the state was on this directory. But if I'm working with more than one person or we are a team, so it is not only me, then this state file must be stored in a shared place. And again, it is secure place. Okay. Terraform Show. So we show how we see how Terraform Show can display the state, and we also see that Terraform state command. No, this is Terraform only show, and the Terraform, of course, state which has many switches, and the Terraform state is usually it's a command that can help me for slice and dice the information. For example, I could understand which resource, which name, and so on. It's like, slicing or, you know, um, understanding the information of the resources. And of course, many switches, for example, list, MV, and many others, I can use it for many cases, for example, like modifying the Terraform state. And this is why I told you before, there is a read-only switches like list, and there is some writable switches like move, for example. So for example, I can rename the resource in the state file. I can move the resource to a module. I can move a module into another module, or remove a resource or remove a module. So all of that using the state switches. Okay, let's get back to build the infrastructure to our demo. Okay, so build the infrastructure. So what I'm going now is just, I think before that, I needed to create something. Let me see. Yes, okay. I think I wanted to show you something else here. So what I will do here, as you can see, this resource group which created by Terraform, and if we look at tags, we can see that there is no tags, right? So what I'm going is just to create a tag. Let's say, for example, YouTube, or maybe live video. So what I'm trying to do now, as you can see, is I make a configuration drift. So I mean this configuration here in the resource on the cloud, but it is not either in the state or not in my configuration. For example, my configuration, if I open the main TF here, it doesn't include this tag, right? And also the state. This is why I take this. So as you can see, the tags here is null. So what I made now is just a configuration drift on the real infrastructure. And let's see how we are going to do with this. So what I'm going to do is I will just run a command. So to show you here, Terraform refresh. So Terraform refresh, what will Terraform refresh? It will reconcile the state. Let's see that. Can you see that? This is a temp file for the lock info created. Now it's complete. So let's open this file now. Let's even open with Notepad. And if I copy that, if I put it with WinMerge, This is the backup. And this is also very important, by the way, because the state it changed, so it create a backup. And all the command that change the state, it create a backup. But for the actual state file, let's copy that. So as you can see, the tag here is null, but the tag here is live video YouTube. So by doing refresh, it just reconciles the state to understand the drift inside my my configuration. And of course, let's do now another thing is now I understand there is a drift here. So now let's say just to remember once I yes, let's output a plan. So Terraform and then plan. And in this time, I will use an output and I will put here the name of my plan, which is new plan. So this is different because I'm going now to execute the plan, but in just to be, you know, hard coded in a file system. So it will not just be to the command line output, but this will be written to a file. So this is very important. So the output, it is the same. I mean, usually it just put the plan output. But what is new here, as you can see here, I have a new plan file. But let's look at the plan here. Can you see that what happened here? It will delete. We will understand what is the means of each symbol here. But as you can see, it marked this as deleted. Why? Because running the configuration will delete this tag because it is not part of my configuration. Someone just making the environment to be, you know, just I mean, it changing that without changing the configuration, which breaks the immutable environment as we explained before. And also, this is why this is also explaining the symbol with that this is going to change. We will explain very well because this is all of that is a potential question in the exam. Okay, so let's now, as you can see, this plan saved with a new plan. So unlike the previous execution, now I save a plan. So now let's run Terraform, not from, for, and apply, and I will just give my plan. So this will execute exactly the plan that I want, which is the new plan. So as you can see, resources 0 added, 1 changed because it removed the tag, right? So let's get back here to the resource. Of course, it was here. So if I refresh now, we'll find that the tags disappeared. So there is no tags. It doesn't have to be okay. So, okay. So this is for this part. Let me remember. Let's clear here. So now we're talking about okay, also let's talk about, but it's not important to show the state or the we already talked about that. Okay, let's back to the slides. Let's take the takeaways or the giveaways here. Okay, Terraform refresh. So as we explained, Terraform refresh, it's all about reconcile or refresh command is reconcile, sorry, the the state file. So for example, it's just understand what is the configuration drift and reflect that on the state. This is why, based on the backup, so what Terraform did is it's create a backup, and as you can see, it just runs a refresh. So it just found that there is change in the actual environment which is not presented in the state, and this is why it marked this tag to be destroyed next time. So if you execute the plan, so it's very important to understand, what you are going to use with or how the refresh is working. Another point or is working with Terraform plan out. So it's just saving an execution plan with the out flag to ensure your Terraform can apply operation run exactly as exists in the plan. Instead of just leaving that to the, to the apply, which is it can't guarantee the execution. Okay, okay, and symbols, yes. So as you can see, it is very important, and all of that is a potential question because it will may ask you like if this symbol means, of course, with the color, as you can see, this mean, for example, what does it mean? So as you can see here, this means change resources. This one is mean add resources, and this red is destroy. This one is tint. We will know or learn about tinted later. Okay, sorry. Okay, get back to change the infrastructure demo. But before that, let me see, pause here and see if there is any question from the people while I'm taking the question from the YouTube live. Sammy, I glad to see Terraform from Azure perspective. I learned it from AWS and Terraform Associated one is mostly focused with AWS. Wish me luck. I am right my certification this weekend. Oh, sure. I wish you. You mentioned that you will share the PDF file in GitHub. I don't see anything. Okay, I already answered that. It will be afterwards. Keep watching, press, click watch and or press watch, and you will get notified with when I update the PDF or the files and resources. Okay, let's continue then. So change the infrastructure. Okay, so now I'm going to run or complete the next part. So let's now update the main TF or changing the infrastructure. So now we're building the infrastructure. So let's change the infrastructure. Mm, so what I'm going to do is, so as you can see here, I just going to add some tags. And let's now, here, sorry, Terraform, Terraform, we will say, let's create plan out, new plan 2. So this will create a new plan. As you can see, it's also showing here that it will change the tags and it will add these two tags, environment Terraform getting started, and here teams DevOps. So let's execute apply new plan 2 this time. Now it's completed. Let's get to Azure resource. As you can see, the tags here, no tags. So if I refresh now, let's refresh. So as you can see, this is the tag environment Terraform and DevOps. And of course, if you want to see them as a list, so this is the tags created now. Okay. So now inspect the current state using Terraform Show. Okay, let me here Terraform Show so we can see the state. And of course, it will including the tags as you can see. Terraform state list. This was list, which is the resource group. Now let's destroy the demo of the destroy. So here I will say Terraform destroy. So as you can see, this is just including and with this symbol, which means that it's going to destroy all of that. So I will just confirm here, and this is going to destroy all the resources. While destroyed, let's prepare for the next. If I even try to make refresh now, still here. So the resources was not found. If I let's refresh again, Terraform. So just give seconds. So as you can see now, the resource group is completely destroyed. Okay, so let's get back to the slides. Now we change, we destroy, create resource dependencies. Yes, but I think, okay, let's create the resource dependencies before, yes, let's create the resource dependency first before we go for the nodes. Okay, to create the resource dependency, let me start by, uh, this is just, this is just a network. So what I'm going to do now, this is just creating the resource group. So let me just Terraform apply because I need the resource group to be exist. So this will create the resource group. Just to confirm. Okay, now it's created the resource group while about refresh. So what I'm going now, we have, as you can see, we have here one resource. So this and no, this, yes. So I will add another resource, which is a virtual network, and the name or the ID is VNet. So as you can see, this resource required a resource group. I mean, if you don't know Azure, as I explained, resource group is just a container that you start to put all your Azure or your cloud resources for Azure inside this resource group. This is why if I want to create an Azure virtual network, I just need a resource group so I can create this. And in order to do that, as you can see, I just need to put a resource group. So here I put the resource group here, which is already now created. So for example, if I refresh here, as you can see, this is a resource group. So let's save this and then oh, let's run Terraform apply. So what will happen now? It just will create a virtual network inside this resource group. This is just for confirm. This is just confirmation about creating the virtual network. For people asking about the screen blur on the YouTube live, there is nothing I can do about it. I think your connection maybe because I have here a very speed connection. Okay, now it's completed. So let's get back here. So as you can see now, my virtual network created. Okay, so let's destroy that. So as you can see, let me destroy and explain. So as you can see, when I create the virtual network, I just gave the virtual network the name of the resource group because the resource group was already created or was already there on the Azure cloud. But how about if the resource group is not already exist? Which mean that if I gave the name of the resource group, it will not be exist. Which is this is the case now in the configuration file. This is why I wanted to show you what will happen. Just to give a few seconds. Now it's complete. Now it's destroyed. We don't need to check again. Just apply. What is different now? Apply now is not just to create the virtual network. This apply, it will create the resource group and the virtual network. But what is the problem here? That inside, let's say yes. But what is the problem here? Inside the virtual network, I just give the name of the resource group, which is not already exist or which is not exist. So as you can see, this is an error happen because it couldn't, create, it couldn't create the virtual network because it just expected that this resource group here, I put it here, this resource group. So what I need, instead of having specified the resource group, I just need to give here a variable instead of a hard-coded value. Let me put it here. So as you can see, for example, here, here I will not just use the name of the resource group, but instead I will use the name of the resource dot the ID of the resource dot the property that I'm asking for, or that I want to have. In this case, this is the name of the resource, this is the ID, and this is what we called usually all of that what we called the resource ID. In this case, what we called here, or what happened here, this will build what we called implicit dependencies. I mean, by just giving that, this will tells or this will tell Terraform that this one must be created first, because if I want to have this property, it means that you just need to create this one. Even if I put that here, I mean, the order is not important at all. As we explained, it's declarative. Terraform is declarative. But the main idea here, this create implicit dependencies. And now Terraform understands. So just save this and start running again. Let me see what happened here first. So of course this is leaving the, let me delete this so we don't confuse ourselves. I will just delete resource group. I will even make to make sure that I don't need this plan. I don't need this plan. I will also delete the state. So just, so as you can see, I just deleted this resource group. Okay, so as you can see, it's deleted. Let's apply now. So as I explained before, I just put a variable instead of a direct resource. So this create implicit dependencies, which mean that it tells Terraform that you need to create the resource group first, and then create the virtual network that use this property, which is the resource group. Okay, let's prepare for the second demo while we're doing that. Run Terraform. Now it's completed. Let's wait for seconds. So if I get back here now, so as we can see now, and I have that. Okay, let's now move to the second part, which is dependency tool. So, creating a virtual machine in Azure, requires many resources, like for example, virtual network. This is the username and password, and the subnet mask, public IP, network security group, all of that. So all these resources. So let me here take this. So what I'm going to take here, this is the network. So starting from here, I'm not sure if this is the virtual network because I just put it because I don't think the resource group is already here. So just I put all the resources for the virtual machine. So what is different here? Now we understand that in the virtual network, as you can see, this is the virtual network. This is what we, or here we use a variable, which means implicit dependency. And also the IB, I need the IB to be created after the machine created. So what I will use here depends on, and this is what we called um, explicit dependency. So as you can see, for example, I put here depends on, and then I put here the resource. So virtual machine.vm. So if I look here, for example, for the resource network, yes. So here, as you can see, this is the resource dot the ID, or so the resource ID Azure RM virtual machine dot VM. So I put depends here on this IP, which mean that this resource, which is the IP, will not be created until this resource is created first. And this is what we called explicit dependency. Okay, let's save. Um, let's run Terraform apply. So here I will put the password, just any strong password. And by the way, as you can see, the password is displayed in the output. I can mask this password, but even or however, if I mask it, it still will be saved or stored in the state file as a plain text. And this is really very important question for the exam. And this is the username for my virtual machine. Just to confirm, yes. And while it's created, let's go for the slides so we don't waste time while creating. Okay, let's look at the takeaways here, information. So we understand now about Terraform destroy, right? So Terraform destroy, it just or remove infrastructure, uh, that you just applied them. Um, and this is just what it's, and again, it just waiting for your approval first. We also here have the value, which is define a list. So when you see square brackets, this is define a list. And the list is just a sequence of comma separated values. When you see square brackets around an argument, it tells you that this argument accepts more than one value. Let me show you here where this here. For example, if you remember the subnet, where it is, yes, can you see address prefix? This is a square brackets. It means list. Is there is any? Yes, here. Address space, square brackets. So it is list. Again, all of that is a potential questions. Like it will give you the square brackets and, for example, asking you how to define a list. If this is a correct list, or maybe asking like if this this is square bracket, what does it mean? So it's either the, the vice versa. It can give you the square bracket and ask you what does it mean, or it can ask you for the list and how to use it, and you will choose the square brackets. Or so you just need to be, careful about all this trick and tips. Let's get back to the create required resources for VM. Yes, we explained that the virtual machine require resource group, virtual network, subnet, network interface, and so on. And we talk about um, implicit dependencies, and implicit dependencies by just, again, give a variable to one of the resources, which mean that Terraform will be intelligent enough to understand that there is implicit dependencies on this resource. So it will create this resource first. And the explicit dependence by just because you understand, because in some cases, or you don't need use a property in the resource, and you just need to create or controlling the dependencies. So you can control that by using depends on, but just to be careful about that, because this is you control the you know the running order of the resources. So you must exactly know what you're doing. Okay, so as you can see, this is exactly what I explained to you. In the first example, we're just using a hard code name of the resource, and this was the name of the resource group, right? And by just changing the name of the resource to implicit dependence, which is type dot name dot property, and in this case, it become Azure resource group dot name. This create implicit dependencies. It means that Terraform will understand to create this first and then create this first by the implicit dependency. But if you're just using hard-coded, again, it just expect that this resource already exists. Again, all of that is a potential questions in the exam. Okay, before we go for this demo, let's see what happened. So if I refresh now here, as you can see, the virtual machine is created. Okay, okay, so let's move to the demo of defining input variables. To define an input variable, let me, should I destroy this? I think the best option is to destroy. Yes, let's destroy. Let's destroy the current. I'm building the input variable because we just need to create it. This is from the beginning. Oh, it's my bad. This should be the password. Of course, this is the password for the virtual machine. And here, yes. So this will destroy the virtual machine. While this, let's create prepare for the next. To prepare for the next, let me start here. Okay, so as you can see, what I'm going to do now, I'm just going to create a new file to put my variable here in this file. So what I will name the file, just variables.tf. So I will just see here echo. So as you can see, this is just created this file. maybe this could be confusing, but anyway. So I'm going to take, so as you can see here, what I'm going to take is, or let me open with Visual Studio Code. So as you can see, I just going to declare some variables. So as you can see here, I just declare four variables. The first is location, and the empty uh, curly brackets, it means it is required variable. So you can't skip that. And here the second variable is prefix. And as you can see, I can define the types and also I can put a default value. And the third variable is type is called tags and the type is map. The map is just a key value, data type that you can just declare, in this way. As you can see, we have key value. So this is the data type of this variable, which is called map. And as you can see, you can define the map by typing type map or by just putting in the default the list key and value. So this is also a map, the SQ. So as you can see, this is the four variables that I'm going to use in the next demo. Um, so let me see here if let's refresh. Okay, it's just completed, but just okay, leave it until we. So here now I create the variable. Let's create the input for the variable. So as you can see, terraform.tf vars echo, and I will just come here. Where is this variable? So this file, I will just put the value for the variable. So just imagine that I'm using this file so I can pass the parameter. So as you can see here, what I did here in this file, terraform.tf vars, I just put here the value for the variables. So for location, I put it west US 2, and for prefix, I just put TF. So we still have, yes, this is for the location. But if you remember, this is a variable, yes, for location. Yes, we just need the SQ, right? So if you look at my file here, let's look here at what happened. So this is destroyed, as you can see. So if you look at the SQ of this virtual machine, you will find that uh, just SQ. Yes, so as you can see here, the SQ is just, this is the version, which is Ubuntu 16.04. And this will just give the code, but I can, using lookup, sorry, let me change all the line. So as you can see here, the SQ lookup, this is a function, and this function taking a key and value. So this is the keys that you will search. This is the keys, the values that is looking for, and this is the key that it will search with. For example, it will just go for, no, here, I mean looking at the location. If the location is west, then if the location is west, then it will just take this SQ. If the location is east, then it will just take this SQ, which is Ubuntu 18.04. So, so as you can see, it is based on the lookup, and this will be dynamic. So if I change here in the variable, sorry, in the value, instead of west US2, if I put the east, this will create Ubuntu this version. But if I put it the west, it will create this version. It is clear for everyone? Let me pause here and take any question. Let me also look at the question on the quick question. The implicit dependency value is defined later in the code, while in the VNet definition, we're already defining the variable of resource group. Want it? It is not clear for me the question. In VNet, we are already defining the variable of the resource group. It's not clear. You can ask your question in a different way. Can we able to use key vault reference for password? Yes, definitely you can use the key vault for the password. It just and this is what is recommended to use a key vault or secret management tools or platform in general. But the main idea, even if you're using key vault, but still executing the Terraform will store the secrets in the state. And this is why it's very important to understand that you have to store the state in a secure place. Okay, now let's get back here. So as you can see now I configure that. So it is based and because now what in my value? It is west. So which mean that this will create 16. If I put it east, it will create 18, right? Let's see and run. No, let's run Terraform apply. And again, so mm, and the username, yes. So as you can, now I'm going to create a virtual machine, and as you can see, I just use the lookup, and it will be depend on the location. It will create different SQ for the virtual machine. Do you want to create ISD? Okay, so this will create the virtual machine. While it's create the virtual machine, let's look at something else. What we can define embed variables. Okay, okay. Let's get back to the slide. Define embed variable. Finish. Okay, okay. So variables tf. So we saw using the variable .tf file. So just again, the variable tf file, as you can see, it's just a file to hold and declare all variables that you want to use them inside your configuration file. And we use the syntax var name, um, terraform.tf vars file. Uh, sorry. So as you can see, in order to put the value for the variables, we created a file terraform.tf vars, and we start putting all the value. It's like an arguments for for the value for the variables in the var file. So this just holding all the value. and it should be presented in the current directory, and it will automatically load it, or automatically load the variable with this value. We can also have another name, like any name dot auto dot tf vars. Again, tips and the tricks for the exam, this all of that could be potential for the exam. Like for example, it could ask you what is the variable file name, and in this case you will say variable .tf, and this is for declaring the variables, and Terraform to tf vars, this is for declaring the value. So all of that is potential questions, and it going to confuse you about maybe the extension. So be sure about the extension. Maybe for example, it removes the s, instead of tf vars, it would say tf var, so just be careful about the information. Map data type. So as we can see, we saw the map as a data type, and we explained that it is just a collection of string value grouped together. And a variable can be have a map either by assigning it explicitly by say type equal map, or it can be implicit declared using the map by specifying a default value, which is a map. And again, this is also potential question. If it's give you either the map and ask you what is this type, and then you need to choose it's a map, and maybe ask you how to declare a map. It's only one way to declare a map. Again, with all the keywords I'm explaining to you, it's potential questions for the exam. Uh, okay, let's move forward. Object. Yes, this is also very important point I found it. I mean, because the map is it is the same value. It's a group of values grouped together, but it's the same value. Sorry, the same type of value. If you want different kind of values, then you don't create a map. You create an object. Like for example, the object can has a string, pool, you know. So it could be also this is a confusion, or a tricky point in the exam. Like give you are going to use a type, a map, or an object in the question, and you need to figure out. What else? Yes, we talk also about the lookup function. In the next sessions, we will talk about many functions of the built-in functions in Terraform, but now we talk only about one function, which is lookup. And as you saw, it's just a dynamic lookup in a map, which just take the values that you want to achieve and the keys that it will search with. So again, this is all of that is a potential question which can confuse you with that. We're using .var, dash var. This is if I don't want to prompt for the username and password for, you know, when I put the username and password for the virtual machine, I can just type dash var and just pass the username and password directly. Okay, we are very close, so don't worry for people. So let me get back here. So as you can see, now it's completed. If I So now the machine is completed, and this is my virtual machine. So this is the IP. Let's have now, if I say SSHP, this is open port 22. It was in the configuration, by the way. Let me show you that very quickly. Here it was port 22 for SSH, and here it would be. So I'm going to connect to the virtual machine to just display to you the version. The password, it was take it here. So as you can see now, let's clear the screen. So as you can see now, I can check for the version by LSP release dash A. So as you can see, this is version 16.04. And again, this is because the lookup, sorry, because in here I just select West US. So the lookup work on selecting the value for West US, which is this value. Okay, this part finish. Let's run. Yes, let's destroy that. This is password must be. This is a password, not a confirmation. Okay, this will. Okay, while destroying that, let's prepare for the. So what I'm going now is to using the output, and while run the output, we will take or we will see the takeaways. Yes, let's take the output. So here, as you can see, I will just take this output. Okay, while this created, just wait seconds. Let me explain to you here. So as you can see here, what I'm going to use or the output or maybe explain the color here. So I'm just saying I want to output this resources, you know, and as you can see, the value will be the data, and this is how you query, the resources. So data.azure public IB underscore address. So for example, the public IB address here, uh, this should be a resource here. Yes, it's here. As you can see, this is the resource. So I'm just accessing output that. So this will like extracting this information to the output and also give me the ability later to query this information. Okay, let's take like one slide or maybe and then return back to complete the output. So output, so as we explained, Terraform output the value after an apply operation and you query this value using the Terraform output command as you will see in the demo. Remote backend as well. So as you saw, all we work with just a local backend, sorry, a local state file which is existing on my machine. But if I'm working with a team, then I must store that in a sh shared storage space for start, date, and it can be several services. Like for example, it could be Terraform Cloud, which is a service paid by HashiCorp, or it could be Azure Storage Account, or it could be EC32, EC3, Amazon EC3, and this also it will migrate your local state to the cloud once you start reinitialize your project, and it will prompt you for migration. And if you approve, then it will just migrate your state file to the cloud. This will be our last demo, by the way. Okay, so here now I completed. First, let me make sure here I saved this one. So now I have saved, and let's apply Terraform apply. And as you can see, this will password. Just put here. This is the location. Okay, so as I explained, this will not just create, but it will also output the IP address to the command line. And it is not just the output, but also will or will make me able to query this value later. So while we created, let's look at the slide. Mm, so slide not here. See, we talk about looking most of remote backend. Yeah, so we talk about the lock. The locking is very important because the locking, it means that no one can edit the state file while you are running. And since you are now running with multiple users and you shared your state on a shared resource or shared storage, then it must be looking. And most of the backend is auto locking. Um, and it will unlock after it finish the execution. And you can also run apply with dash log timeout if you want to execute the command after a specific time. This is also very important. By default, Amazon S3, you just need to configure the locking. In Azure Storage, it automatically configured. I will show you that in the demo. Uh, yes. So as you can see, this is the output. As you can see, I can also, query this output later if I would like. It's very easy, like Terraform output, and then here public IP, and this will give me so defining an output and extracting this. Okay, let's work on the last demo, which is the remote. We just to just create that, I will very quickly, let's create a new resource group. Let's say uh, storage. So I created resource group, and inside this resource group I will create a storage account that I will use to store the state. Just to give some times. We still have some other demos, but maybe we can, because I don't want to, for the next time with the next session. Let's say the remote state will be the last demo. Okay, so now I have the storage account. See if I add here storage account and let's say Terraform Terraform exam test. So this will create the storage account. Just to give, wait for a few seconds. Okay, so I will create a container. Just remember here, this is the command. So the resource storage account created. So I will just go for container, create a container. Let's say my TF storage. So as you can see now, I create this container. So what I'm going to take first, as you can see, this is access key. Again, I will copy that here. And now I just need to store this key in the environment variable. And again, as the question asked in the YouTube live, yes, it's better to store this value in a key vault, but for this demo, and I will just store that in the environment variable. And to do that, I just say export or just access key equal, and then give the value. Let's make sure echo. So yes, now the access key is stored, which will be the key to access the storage account. What I need else, yes, let's have this value. So I just want to change here the backend. This is the Terraform. I think it's here. Can't even. Let me double check. Or I think yes, it's here. It should be in the Terraform block, but let me double check. So you can know even that. As you can see here, this is the remote state. I just need to know the remote. Yes, so as you can see, I just double check the block. So the back end here. So the resource group, as you can see. So let's get back here to our work. Just put here the resource group or the information field, this information. So this is the name of the container. So here the resource group, I will copy here. Just put it here. And the storage account name. This is the storage account name. And the container name. Container name, it's here. I can't remember the container name. It's my storage. And terraform.tf state, this is the name of the file or the key. So this will be like that. Okay, now I save that. So what I'm going to do now, um, let me show you the state for the last time, just for clear. So if we say Terraform state, let's list so we can see all the backend initialization required. Okay, because it shows the backend. I wanted to show you the list first before let me just comment that. Just a state list. So as you can see, by state list, I listing all the resources. If I say Terraform show, this will show all the state. And again, all of this state, it's a local. So if now I I uncomment that, and also let me show you what exists here in this container. It's an empty, right? So what we are going to do now is just reinitialize the project. So Terraform initialize. So just look what will happen. So as you can see here, it just look that do you want to copy existing state to the new backend? It just found that there is a remote backend configured, and it just asked me if I want to do that. Pre-existing state was found and the migration to the previous local backend, and so I will just type here yes. So as you can see, this will make a migration from my local state on my machine to the remote state on Azure Storage. Terraform has been successfully initialized. You may now begin working Terraform. So plan, okay, so now the migration should be completed. Let's refresh here. As you can see, the Terraform state now exists. And if I open that and moving to edit, we can see the state now it's here. And once I create anything, it will just, very important also. Let me show you, for example, if I'm here, um, this is very important. Last state unlocked. Can you see that? because this is very important. Just imagine I will destroy that and this will be lost today because yes, we are late for 10 minutes. Okay, Terraform destroy. So what will happen now? Oh, sorry. Uh, Terraform destroy. So Terraform destroy, it will just here, this is the password. Here, the username, the location. I have very bad memory for people that they know me. Just to confirm. So just see here what will happen here for the state was unlocked, right? So if I refresh that, can you see? It's now logged. So this is very important because now no one can run that because this is logged and after it will complete either, it's not just with destroy, but with every command you run because it write to the state, then it look. And as I explained, this happen automatically here in Azure Storage, but with Amazon A3, for example, it require configuration. Okay, while this, let's get back to the slide very quickly. Okay, we will get for this next time, but for that, yes, we reach it to this point. While this created just again, please, I would like to hear your feedback because I mean, if it is the session was useful, you would like to attend the second session and the third session, or because there is no point to continue if it was not as expected, or so please, I would like to hear your feedback so we can continue. And also, if you have a question related again to only for the three main objectives. We didn't complete all the objective yet. We just the small parts, which is FMT and TEND and all of that. So if you have any question related even to the three objectives, please leave them on GitHub. Thank you, but let's look at yes, I just want to show you here what will happen after the destroy or after the completion of the executing the plan or applying or whatever, this will be leased and the lock will be unlocked again. We can see that, of course, while it is just writing to the state, this will never happen. But I think that's it. It will be unlocked and you don't have to see it. But I know that you trust me, right? Okay, any question?
Hello.
Hello?
Yep. So I have a query in terms of the last command which we executed, that is to Terraform destroy.
Yeah.
If I understand correctly, does it destroy all the resources that we have created in past few hours?
No, everything is based on your Terraform configuration file. Just imagine that when you write any command, it just scan the current directory for all the Terraform files. And based on what exists and the state file, it will understand what the state file, it gives what is the current state. And the configuration file, the TF, it's explain what is the desired state. Okay? So comparing that and that with the command. So to just not confuse you, it is based on scanning the current directory that you are running this command in.
Okay. And second thing is, I understand that we're gonna have three sessions to cover up the whole objective, right?
Yes.
So when do we expect the session 2 and 3? Will it
Again,
be
based on the feedback, as I explained, because there is no point to continue with the sessions without hearing your feedback, what you expect, the questions. I I got more motivation by the involvement and and activity, interactive people going and tell me, like that. So based on the feedback,
Okay, thank you.
no problem. Okay, I think maybe it's completed now. Yes. So as you can see, this is logged here. As you can see, if I make refresh here, this will be unlocked again and this will be available. And all what you have seen, what I explained with all the points, it's a potential question in the exam. So as you can see, if you cover all, this is not even the complete three objectives. We still, but if you cover all the points that I explained, you will completely cover that. And if we cover all the rest of the objectives, this will be completely, uh, I mean, cover all the exam. Uh, People asking the link for the feedback. Okay, I will send you the link. Of course, you still can feedback on the, but I don't prefer the feedback on the live because this will be just record in the live. I would prefer the feedback on the YouTube. I will send email for all of you with the links to give the feedback. It will be the same link for the YouTube video. And that's it. Any other question or anything? Thank you for your patience and for waiting extra time. It's more than 16 minutes. But I hope the session, and I would like to hear the feedback if the session was really useful or not. Okay, thank you. Then